Okay, we're going to just review a few things really quickly, vocab-wise, and then I'm going to work a couple examples off the worksheet for you as well. If you're talking independent and dependent variables, the independent variable is the one that you change directly. It's things like time is always an independent variable because time is always changing. It doesn't depend on anything else. Dependent variables are variables that depend on the value of the independent variable. So a dependent variable would be something like distance, position, money, because it usually depends on something else. We can see in this example, the amount of money Carl makes would depend on the number of lawns he mows. So money would be your dependent variable, and the number of lawns would be the independent variable. We've talked about this before in class, but just a quick review today. When you interpret a graph, always remember that you need to be paying attention to what X values or what part of the graph they're going to do. If they don't tell you, if they give you a range of values, taking the time to mark it on your graph is probably a good idea. Always, when you get your answer to, just think, does this make sense? Because that's going to help you out. When you're dealing with increasing and decreasing. Increasing means as you go from left to right, the graph is going up. So this graph would be increasing. And then decreasing means it goes down. So if it turned and then started doing this number, the blue part would be increasing, the pink part would be decreasing. So increasing there and decreasing there. If a graph is horizontal, it's constant. So you could have a graph that, for example, increased a little bit, and then it was constant for a while, and then it could decrease for a little bit. So that just helps you know you're always going from left to right to determine if it's increasing or decreasing. One other thing worth mentioning is about this acceleration. Acceleration is a special type of graph where time is your independent variable and distance is your dependent variable. And basically what you're going to see is if a graph is getting steeper, it is accelerating. For example, this graph is going up. It's increasing the whole time, but you can see it's going up faster and faster, so that would be accelerating. Now this other graph here, I'll do this one in green, it's still increasing the whole time, but the rate of increase slows down, so that is deceleration because it's the rate, how fast it's increasing slows down. So you can tell this graph, it's getting steeper and steeper, so it's accelerating. This graph is getting less steep, it's decelerating. If the graph is linear, if it's a straight line, I'll do this one in blue. That means the distance is increasing, but since it's increasing at a constant rate, it's a constant speed. So you can basically look at how fast it's changing would have to do with the acceleration and of course this is when time is on your X or independent axis and distance is on your dependent axis. Hopefully this will help you out, and we'll try a couple on the worksheet. So this is on the position worksheet, the one that is the graph story's position. On this one, what we need to do is we need to read carefully. So Roy's riding his bike uphill at a slow but steady speed, but he gets faster as he goes down the other side. So this is time and this is distance. So if I have my time and my distance, basically it says he starts riding at a steady speed. So his distance he's traveled will increase. So you can see this one, the distance is increasing. So I like that. And this one, the distance is increasing. That both works for the at a slow but steady speed part. Now for the next part, I'm going to mark this one in pink. It says he goes faster and faster. Well, this one doesn't show him going faster. This one would show that he stops there because the distance stays the same. On this one, you can see it continues to increase at an ever steeper rate. So this is the one you were looking at. So that would be E. Now, for the same one, you're saying, now for number 2, you're taking a look at Roy, but this time instead of saying it's time and distance, we're going to say it's time and speed. So time and speed, basically his speed starts off at a certain amount. So that would be this. And then it increases as he goes. So that would be this. So I think this one would be graph U. And on your submission form, you're just going to be putting in the letter of the correct answer. You can use your puzzle at the bottom of the page to help you figure it out. But what you're not putting in is the puzzle. You're just putting in like number 1 would be E, number 2 would be U, and so on. We'll do a couple more examples on another video.